Hey, it's Miss Phelps, and this afternoon we're going to be talking about logic statements. So we're going to kind of change gears a little bit, and this may even seem more like English class than math class, but it is actually math, so let's get started. On logic statements. Logic statements are made up of two parts. The first part is called the hypothesis, and the second part is called the conclusion. It is normally written as an if-then statement, and I'm going to show you what that means in just a few minutes. The hypothesis is written after the word if. So for instance, I might say, if there are clouds in the sky. So that would be the hypothesis part. The conclusion is the part written after the word then. So I might say, then it's going to rain. So my whole sentence would be, if there are clouds in the sky, then it's going to rain. So that's my hypothesis and my conclusion. In this next one, I want you to underline the hypothesis and circle the conclusion in the following sentence. If you are a brunette, then you have brown hair. So I'll give you just a second for that. Okay, so my hypothesis is if you are a brunette, and the conclusion is then you will have brown hair. All right, so let's go to the next slide, which is going to be the second part on your handout. And I want you to actually try rewriting the statement in if-then form. So I'm just going to give you a statement, and then you're going to get to rewrite it as a conditional statement. So here's the statement. Vertical angles are congruent. So I would change that to an if-then statement. You can actually do this one two ways. You could say, if there are two vertical angles, then they are congruent. Or you could say, if two angles are vertical, then they are congruent. But either way, you've changed it to a conditional statement. Now, the second part of this is a counterexample. Now, a counterexample shows that a conditional statement is false, so it is not true. All right, and here's the most important thing about it. It must keep the hypothesis true, but the conclusion part is false. Okay, so again, one more time. It must keep the hypothesis true, but the conclusion part is false. Okay, so here's my example. If x squared is 81, then x must equal 9. Okay, well that sounds like that would probably be true, but the problem is that you could also use negative 9. So my counterexample, oops, sorry about that, is that x could be negative 9. So that is the counterexample on that one, because negative 9 squared is also 89, but it's not positive 9, so that proves that it's my counterexample. So we're going to actually be doing quite a few of these in class over the next several days, so get ready. I'm going to stop there and hope you have a great day and make good choices.